May this knowledge and understanding bring love, joy, truth to our lives and to the lives of every being that we can reach. May the world and all living beings everywhere be free from suffering and experience joy and have the opportunity to learn and grow everywhere and forever. Great. So everyone knows there are very small numbers, and everyone knows there are very, very big numbers. And the number of zeros that we put behind the numbers keeps on multiplying that number by 10. Every zero multiplies it by 10, and so on and so on and so on. And we can keep going forever. And if we put that big, big, big number into the denominator and take the rest, so in other words, take the reciprocal of it, one divided that by that big number, we will end up with a very, 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 very tiny number. And if it is in the matter of length, then it will be a very small size. If it is in the matter of volume, it will be a very, very small, um, you know, uh, element or atom or some such thing. And if it is in length, it's a very small distance. And if it is time, then it is a very, very small unit of time. And, nanoseconds, microseconds, femtoseconds, picoseconds, and so on and so on. So this, everyone knows milli, which is 1,000th. Everyone knows maybe micro, and then so on. But as you keep going, these names, we will see what these names are. But the smallest number that has been given a name is 1 divided by 1 followed by 24 zeros. So if you take 1 and add 24 zeros behind it and divide 1 into that many parts, 10 raised to power 24, 1 followed by 24 zeros, then you get what is known as a Yocto. So a Yoctometer is 1 over 1 zeros meters. And then if you go to the other end of the spectrum, actually not the full spectrum, but the limited spectrum of named numbers, named in this form, and you take 1 and you add 24 zeros to it behind the 1, you get what is known as a Yotta. So there's a Yotta in the large scale and there's a Yocto in the little scale. And if you do it in terms of time, you'll get Yocto seconds, which is a very, very small, tiny time interval. And if you make it in terms of distance, it's a Yotta meter, which is a very, very tiny amount of length. But my really, we know this, we all know this, but my quest really was something beyond just knowing what these names are and what these numbers are. It was more about how do we get a sense of how big this is or how small this is. How do we get our wrap our brains around it to know what this means even? And we are talking, there are numbers even, of course, bigger than this. But before I plunge into this, there are a lot of people who are new to this Discovery Cafe and have joined for the first time. So let me give just a a 5-minute overview of what we are up to. So of course, as we all know, that in the world there are literally you know so many subjects, so many areas that we can understand and know about. So the this wave called catching the wave, the Discovery Cafe is about looking at anything that's in the outer world, whether it's astrophysics, acting, history, photography, music, design, movies, books, dance, mathematics, physics, archaeology, art, and so on. You name the subject, it's out there. And if you go in poetry, and if you go into any of um, these topics, there is a whole wealth of understanding. There's a wealth of information. There's a beauty. There's so much depth. I mean, I personally, gravitate towards some of these areas, and I'm sure some of you relate to each area more than some of the others. But the basic understanding is that we can all understand and at least to the level of being able to appreciate each of these subjects. Each of us can know what is in that particular area. I may know nothing about dance, but I'd love to know a little bit more, little bit enough that when I see someone dancing or composing or choreographing, then I would be able to appreciate that dance a little more because I know something about it. So knowing a little about a lot, okay, and then knowing a lot about a little, and then bringing that all together in a way that we unravel more and more mysteries that surround the universe and surround our lives and are all around us, so that we basically, what is the purpose? The purpose is to learn. And what is the purpose of learning? The purpose of learning is to know. And what is the purpose of knowing? The purpose of knowing is to enjoy. And what is the purpose of enjoying? Is to be happy. So ultimately the purpose is happiness. Like most of endeavors of humankind, it's happiness is the road driving force of all of it. And if you think about it, happiness is also the driving force of all spiritual endeavor also. So whether you talk about meditation or yoga or bhakti or devotion, prayer, all of those, becoming closer to our true selves, becoming closer to the divine, that is also ultimately a quest for happiness. So the Discovery Cafe heads towards happiness from the outside towards inside. So we take what's outside in the outer world and go more and more towards what's inside. And we have another group called the Open Door, Open Hearts, which is about going inside towards outside. So that once we know the deep truth about ourselves and our lives, how can we bring that truth to the outer world? So they all both meet in the outer world, but the starting points of the Discovery Cafe and the Open Door are diametrically opposite. And with both of them, we meet it out here in the real world, in the practical world, in the world of our lives, in the world of our day-to-day activities, and see how this knowledge of physics can impact our interaction with people, with ourselves, with our lives, with money, and so on. And same thing with the inner discovery or the inner journey. So so we've been taking different topics every time we have the Discovery Cafe meeting. And we've done some sessions on movies, on astrophysics, on poetry, on art, and so on. And we've had a bit of a break for a variety of reasons, but now we are restarting this. So today we are looking at mathematics. So mathematics we have not touched before. So mathematics is what we want to look into today and see, you know learn something about numbers, learn something about what are the extremes. We have looked at the extremes of music. We looked at what was the slowest song in the world, which is going to last like 600 years. The entire duration of the song is 600 years or a little more than that, and so on. So here we want to look at the limits of mathematics. What are the outer edges of numbers specifically? Not just all of mathematics, but the mathematics of numbers, which is a very, very important part of a branch of mathematics, right? So that's what we are up to. So everyone, I hope, is in the Discovery Cafe group, or if you have not, then please uh, post your numbers in the chat window, and we'll add you to the group for the Discovery Cafe, and also for the Open Door, the inward to outward journey. So, and everyone is welcome to both. So we go forward with this. So like I said, we are going to look at the smallest of scales and the biggest of scales, and see if there's a way we can get a feel for what how small is small? Exactly how small is small? We know atoms are small. We not only know they're small, we know they're very small. But exactly how much is very small? I mean, when we think about like small things, what are we able to even visualize? Like the head of a pin or a grain of sand. Okay, we know that's a tiny, tiny thing. The a mustard seed is a little bigger than that, and then so on and so on. But the smallest thing we can think of is like the tip of a needle, maybe, or the or a grain of sand. But that's not the smallest there is by any means in the universe. There are things that are much, 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 as in thousands and millions of times smaller than the grain of sand. So what are those, and what does that feel like? How do we get our heads around, how do we wrap our heads around how small that is? So what I came up with is one way to understand how small something is, or even how big something is to get a feel for how long it might take to count it, right? So if I if I hand you a fistful of sand, and I want you to get a feel for how small each grain is without really being able to see each grain. Let's assume we don't know how to look at, we couldn't see the grains, but I give you a lump of sand, and I want you to have a sense of how small the grain is. Then if I tell you that to count each of these grains would take me a day, it will take me a day to take each one of these and count each one. then I then it may take more also, yeah. But then if I see that, then I get a sense for, okay, it must be so tiny, because it fits in my hand, and yet it takes me a day to count all of them. So there must be a whole lot of these, and they must be really tiny. So to be able to get a sense of how small something is, or even how big something is, if I tell you there are in the universe, there's one followed by 24 zeros, stars. Okay, one and then 0 0 0 0 0 0 24 times. That's how many stars there are in the universe. But I don't know how many that is really. I mean, I look up and I see a lot, yeah, but how many is that? So what I came up with is this counting machine. So assume that we have a counting machine that can count anything, not just money, but it can count anything. And so a typical counting machine in a bank counts about 1200 notes per minute, right? So about 20 notes per second is the rate typically at which the faster machines of today can count money. 20 notes per second. In 1 second, 20 notes, 20 notes, 20 notes. 1 second, one, 20, 20, 20, 20. That's how fast it's counting. Um, so let's assume that we can use this machine not just to count notes, but to count anything. And it's going to count anything for us at the rate of 20. But you have a sense of what a banking cashier counter machine feels like, looks like. You have a sense of that, so you know how fast it is moving. So let's assume it can count anything. It can count grains of sand, it can count people, it can count anything. But that's how fast it'll do it, as fast as it counts notes. So at the same rate of 20 per second. Okay, now one of these machines counts 20 every second, but for the numbers that we want to count, this is not enough. Okay, 20 a second is too slow. But to still get a sense of what it is, we cannot simply multiply the speed, because then we lose sense of how fast that is. So what we are going to do is imagine that we have a room with 100 such machines, right? So 1 2 3 4 5 6 7 8 9 10, 10 times 10, hopefully I counted correctly. So there are 100 of these machines, right? And so there's a big room. Just close your eyes and think of a room, a big warehouse kind of a room where we have put 100 machines on tables, and there are, let's say, 20 desks, and there are 5 machines on each desk, and each one can count at the rate of 20 per second. And there are 100 of these in a room, and we can put them all to work at the same time, counting whatever we are counting, and they're counting at the rate of 20. Okay. Oh, so 100 such machines, fine. And we want to make it even bigger than that. So imagine now in your mind's eye that you have not just one room like this, but you have 10 such rooms. One room after another, there are 10 rooms. And 10 is still a number we can put our brain around, right? So imagine there's a big office with 10 rooms in it. Each room has 100 machines, and they are all counting at the rate of 20 per second. So we have 10 times 100, which is 1,000 machines, and each one counts at 20 a second. So this whole collection of machines together is counting at a pretty mind-boggling speed of 20,000 items per second. Okay. So this machine, we're going to call the count calcula machine. Pardon the pun. So count calcula is going to count whatever we want at the rate of 20,000 per second. Okay. So this is our machine. Everybody got this picture of this machine of 10 rooms, 100 machines in each room, and each machine can count 20 things per second. So our total capacity of this counting factory is 20,000 per second. Okay, 20,000 per second. 20,000, 20,000, 20,000, 20,000. And now we are going to start counting these big numbers and see how long it takes. And that's going to give us some sense, in a way, like, okay, it's that many. Okay, how much is that? So let's take this baby count calcula for a little test drive to help us count some of the bigger numbers that are out there in the world. So anyone has any questions so far? No
Sanjeevji,
question? Ha, bolo.
instead of using 100 machines to
Yeah.
count 20,000 notes per second, we can't make one machine to count 20,000 notes per second.
No, because the real machine that we are used to, see, the whole idea of this exercise is to be able to
Hmm.
visualize these numbers. So we know what a banking
Okay.
machine looks like today. It counts at a rate of 1,200 notes per minute. That's a typical banking machine. And we have all seen it.
Yes.
वो drrrr
Uh,
ऐसे चलता है. Now, if I make that
yes.
one machine count 20,000, we have no clue how fast that is, because it just
Yes.
goes too fast. You imagine one thappi hoti hai jo of 100 notes. It'll do
Convert
in
the.
it'll do
Uh,
in too fast. We won't even be able to follow it. So that's
yes.
the point. And it has to be something we can visualize. That's the whole idea, right? So yeah,
Hmm.
but good question. So we can't make them, but at the end I'm going to show you one machine that helps us visualize very, very big numbers in a different way.
Hmm.
But this is what we are going to use for now. Okay. So here we go.
Yes.
Yeah.
Thank you.
Yeah. Great. So here we are. We got this count calcula machine ready to go. And now we're going to take this calcula machine for a test drive. So, so let's say we are going to count 10 million rupees. Okay. 1 crore rupiah. We are going to count it, and they're in 100 rupee notes. Our machine of 20,000 per second will finish this job in 5 seconds. 1 crore rupees, brrr, gone. 5 seconds is done. And we know what a crore is like, right? I mean, 100 लाख रुपया, 100 की थप्पी में एक 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 थप्पी 10,000, एक थप्पी किया तो 1 लाख, वैसी 100 थप्पियां वो 5 सेकंड में गिननेगा. Then we know how fast this machine is. This is really fast. So supposing we want to count how many people there are on the planet, approximately 7 billion are there. Now, billion is 7 followed by 9 zeros. Okay, 7 billion means 7 and then 9 zeros gives you a billion. So count calcula would take 100 hours to count all of us. Okay. It'll take 100 hours. So even though it can count a crore rupees in just 5 seconds, it'll take 100 hours to count all 7 billion people one after the other. Now, this is an imaginary thing. Our note machine normally counts only notes, but supposing it's able to count people at 20,000 people every second, 20,000 people every second, fat, 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 fat. But it would take 100 hours to count all of us. Okay, Mukesh Bhai Ambani has an estimated wealth of about 6 lakh crores, okay, which is about 6 trillion rupees, which is 6 followed by 12 zeros. Okay, that's how much money he has. If you stacked it all up in 100 rupee notes, our count calcula would take 18 days to finish counting all his money. 18 days at that rate, at that incredible rate of 20,000 notes per second. It would take 18 days running 24 hours a day. It'll take 18 days to count all the money that Mukesh Bhai has. Okay, so that's so again that gives you a little sense of ki, okay, because when we hear a number like this, right, Mukesh Ambani net worth is 6 lakh crores, वो कितना होता है पता भी नहीं है, मतलब it doesn't sit in our head. But imagine now you visualize your factory, your counting factory. It's going to take 18 days non-stop, 24 hours counting, counting, counting. That's how much money he has, guys. So, okay, let's take on a bigger challenge. So, in our human body, there are 15 trillion cells. Trillion is has 12 zeros. Okay, 12 zeros. So the counting of numbers happens in threes. Like there are in between names also. Like you can say million, then 10 million, then 100 million. But the name numbers come in after three zeros. You keep adding three zeros, you get the next. So you have 100,000. Sorry, start with a million, which is six zeros. You add three zeros, which is 1,000 million, which is a billion. You add three more zeros, you get a trillion. Then you add three more zeros, you get a quadrillion. Then you add three more zeros, you get a quintillion, and so on and so on. It goes on. I'll show you how that whole numbering works. But it's three zeros at a time, thousand times, thousand times. You keep adding. So 15 trillion cells. I mean, so we can't even get a sense, even though it's our own body, it's our own we are so familiar with our own body. But to get an idea, okay, ek cell, there are 15 trillion of them. Now, supposing I'm using my count calcula to count these cells in the body, then it's going to take 45 days. Okay, 45 days. One cell I'm going to count in my calcula machine at the rate of 20,000 cells per second. It's still going to take 24/7 of these factory running for a month and a half before I can count all the cells in one human body. Okay, so we can get a sense for how small this thing must be. This cell has to be so tiny that it even this fast rate, it'll take 45 days. Now, this cell is actually pretty big compared to smaller things that exist in the universe. Okay, the cell is a giant compared to because it's a collection of molecules. A cell has like literally hundreds and thousands of chemicals, atoms, and molecules, including water and amino acids and DNA, RNA, and the cell membrane, and so on. So a lot of these come together to make one little cell. So obviously, those little things that are inside the cell are even smaller than this cell, right? So let's see if we can get a sense of how tiny we can get. How tiny is tiny? This is a question in front of us. Then we are going to go to how big is big, and and um, and then we are going to understand something about how we understand all this. Okay, great. So So if we go to this scale, which So if you take a one in the order of 10 or 1 meter, which is 3 feet, about 3 feet, that would be approximately the height of a sitting person, 3.5 feet, something like that. A sitting person would be in the order of 10 to the 0, which is 1 meter. And of course, everybody knows a millimeter, which is 1 divided by 1,000 meters. So a thousandth of a meter is a millimeter, and everybody knows what a millimeter looks like, right? I mean, we have all seen the scale. We know what a centimeter is like. It's like this. And then millimeter is like 1/10 of that. So a micrometer, which is 1,000th of a millimeter. So you take 1 millimeter and imagine that you're dividing it into 1,000 little parts. That's how big a blood cell is. 1,000th of a millimeter. You take just 1 millimeter and you divide that one tiny millimeter into 1,000 parts, you get a blood cell. You take that blood cell and again divide it into 1,000 parts. You already took a millimeter, divided it into 1,000, divided again into 1,000 parts, and you'll get one little atom. Somewhere between 1,000th and thousand, again 1,000 of that is one little atom. And then you go again 1,000th of that, and you get what is in the center of the atom, which is the nucleus. And then you go even more 1,000th, you come to what an electron sound is like. So you've taken a person and gone one. Let's start with the millimeter. Everybody knows what a millimeter is like. You go 1,000th part, then you go 1,000th again, then you go 1,000th again, then you go 1,000th again, and you go 1,000th one more time, and you reach the size of an electron. It's hard for us even to imagine how tiny this is. And even at that tiny little scale, there is order in the atom. It's not just any random movements. It's orbiting around the nucleus with specific charge, specific properties, not with chaos. It is full of order and beauty and organization. So this is that. Then you go another 1,000th and then another 1,000th, right? You keep going, divide by 1,000, divide by 1,000, the millimeter, and after you divide that millimeter into so many thousand, you finally come to this great number that we are after so far, which is the yoctometer. Yoctometer, which is 1 divided by 10 followed by 23 zeros, or 1 followed by 24 zeros. That's what the yoctometer comes out to. Okay, so uh, now, how many atoms in a grain of sand? Okay, we are going to raise that question. How many atoms in a grain of sand? One grain of sand. Everybody knows how tiny the grain of sand is, right? So I want to just have people take a guess. Like, okay, so now you know what the size of an atom is. It's a thousandth of a thousandth of a thousandth of a millimeter. But so how many atoms? So grain of sand is made of silicon dioxide. Okay. Silicon and oxygen combine to make this oxide called silicon
Yes.
dioxide. Um, and okay, yeah, sure. And and silicon dioxide is a molecule which is made up of silicon and two atoms of oxygen. One atom of silicon, two atoms of oxygen, SiO2. So how many such atoms are there in a grain of sand? One grain of sand. Okay. I flashed the slide for a bit. Maybe some of you were quick enough to read it, but okay, let me ask you, put the question another way. If we were to use our count calcula to count each of the atoms inside this grain of sand, which is counting, as you know, what speed? 20,000 atoms per second. It's going to count 20,000, 20,000, 20,000, 20,000. Fatafat, this machine is counting at 20,000 atoms per second. How long do you think our count calculi is going to take to count all the atoms in one grain of sand? Any guesses? Anyone wants to take? How long would it take? कुछ तो number फेंको ना, क्या फर्क पड़ता है? We are all in this ignorance together. Even I didn't know the answer to this till I started researching this. So how long do you think this machine will take? Million what?
1 year.
How about 10
Okay,
years?
10 years, 1 year, 1 day. Okay, million, somebody said, I guess they're saying million days, or I don't know, million seconds. What? Vrushali. 5 days. Okay, yeah, please, everyone, post your guesses. 36 days, 1 year, 10 days. Very good. 1 week. Okay, remember Mukesh Bhai's wealth took 18 days, okay? And the cells in our body took 45 days. So just think, one grain of sand, counting all the atoms, kitna din lagega? Okay, so let's go to the answer. All right, so surprise. Everybody's off, by the way. Everybody's off, like way off. It's going to take way longer than that. इतना अपना fast machine बनाया, पूरा factory लगा दिया counting machine का. Even then, it's going to take our count calcula 3 million years.
Oh my gosh.
Yeah,
No.
3 million years.
Cannot believe this.
Cannot believe it, isn't it? 3 million years at the rate of 20,000 atoms per second. 3 million years. Can you imagine how many atoms there are? You're going to count each atom at 20,000 a second. Pop, 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 pop. And you'll be doing it 24/7, day after day, day after day. And it's going to take 3 million years. So this should give you some sense of how darn tiny that little atom is. And we are only talking about one little grain of sand. It'll take 3 million years to count all the atoms at this speed. So this is, I mean, some of us are engineers, we've studied atoms, we've studied physical chemistry, we've studied the Niels model and blah, 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 and electrons orbiting. We even don't have this sense of how tiny this thing is. And at that scale, things start to like behave very differently, which is the field of quantum mechanics and quantum physics. Like things that behave at our macro level that we can see, pins and pianos and grains of sand behave a certain way. But at that scale, things start behaving very differently. Particles behave like waves or like particles, depending on how you look at them. An electron, if you shoot a beam of electron towards a screen, if you put two slits, it'll go through both slits and create an interference pattern on the other side. If you put one slit, it'll just go through the one slit and look exactly like a bunch of dots, as if it's like a little ball. It's like a ball that if I have one window, the ball just goes through that one window. But if I put two windows and start throwing the same ball, it goes out through both of them, either this or that, and then interferes on the other side and makes this interference pattern. So while a ball is a macro object and behaves in this macro world way, the electron, because of this tiny, and you know how tiny now, way thing that it is it behaves like a wave or like a particle depending on your setup and your experiment. So at that scale, the world really starts getting very, very weird, very, very strange. And now there is one. So Yocto, as we know, is now 10 to the minus 24, which is even 1,000 times smaller than an electron. Okay, so we can't even imagine those numbers. But what happens is when you keep going smaller and smaller, there comes a particular number of 10 to the minus 34, which is 1 divided by 10 to the power 34. 1 divided by 1 followed by 34 zeros. When you look at that scale of things, 10 to the minus 34, if you try to go smaller than that, our mathematics falls apart. All our equations of quantum physics, quantum mechanics fall apart. They become what is known as in the physics world as they diverge. They go towards infinity and asymptotes, and all kinds of weird things happen. If you try to make a calculation of energy, mass, and so on and so on, as long as you're working with particles and distances of just 10 to the minus 34 meters, you're okay. Funny thing happens at 10 to the minus 35. It falls apart. It falls apart. So so there's a class of physicists, or there's one line of physics which thinks that there is no such thing possible as smaller than 10 to the minus 34 meters. Nothing can be smaller than that. And according to them, even space is quantized. Quantized means it comes in packets. Packets means it's like you can have, let's say, um, one newspaper, and you can have two newspapers, and you can have three newspapers, but you can't have 1.5 newspapers. I mean, it doesn't make sense. So similarly, space also turns out that you can go to point A and you can go to point B very, very near to it at a distance of 10 to the minus 34 meters. You can go from point A to another point, which is only 10 to the minus 34 meters away from it. But you cannot go to any point between those 2 points, because that will be in the range of 10 to the minus 35. And there, physics falls apart, mathematics falls apart. Now, whether this is really true about the universe is still an open question. Physicists are still debating this. So consider yourself almost PhDs in physics at this point, because now you know something which is very much at the edge of physics knowledge today. Physicists today don't know whether anything can exist beyond 10 to the minus 34, neither space nor length. So it's an open question. And any of you want to do a PhD thesis, it's a wide open field. Go for it. But this scale is called the Planck scale, Planck, the Planck scale. And that number is called the Planck's constant. So the Planck's constant defines how small something can get. And that's in the range of, like I said, 10 to the 35, 10 to the 34. So can you guys see this? That Planck's number is right after here. If you maybe you can see this. Can you read this Planck's constant thing here? Planck's scale. Are you able to see it, or is it covered? Let me move this thing
It's
if I
covered.
can. It's covered. Okay, let me move this over here.
Yeah, we can see now.
Okay, good. So this Planck scale at 10 to the minus 34, that's when physicists think nothing can be smaller than that. But that is still 1,000 times, 1,000 times, 1,000 times, 1,000 times smaller than a yoctometer, which is 1,000 and 1,000 times smaller than an electron. And you know how small an electron is. It's going to take count calcula 3 million years to count it. Okay, so 2 followed by 9. Okay. Sorry, I had that wrong. That was for the grains of sand on Earth. Okay. So 1 grain of sand, I'll go back to this. But supposing we want to know how many grains of sand there are on the entire planet. It turns out there are 75 followed by 17 zeros grains of sand, approximately. Not counting the grains of sand that you brought back in your shoes from your last visit to the beach. We are not counting those. But on the earth, there are this many grains of sand. And it would take count calcula 3 million years. But going back to the atoms, it's 30 million years. Sorry, 30 million years to count all the atoms at the rate of 20,000 atoms per second. Right. So 30 million years means you would have to be born. Yeah.
To count all of the atoms in all grains of sand, or how many for one grain of sand?
This is 1 grain of sand, Karishma.
30 million for one grain of sand?
1 grain of sand. So here's how the calculation goes. So, so Avogadro's number is the number of atoms in 1 mole of anything, right? So 60.8 grams of sand would contain this Avogadro's number of atoms. And 1 grain of sand is about 67 micrograms, which is 67 over 100,000 grams. So a single grain has this many 10 to the power 18 molecules, and you multiply by 3 because there's 1 silicon and 2 oxygen. So multiply by 3 gets you 2 times 10 to the power 19, which is 2 followed by 19 zeros. Now you divide this 2 followed by 19 zeros by 20,000, you only get rid of the 2 and 4 zeros. So you're left with 15 zeros still. And this is how many seconds it'll take. You're left with 15 zeros, which if you divide by, divide by 60 and then divide by 3,600 to get hours, by 24 to get the days, and then by 365 to get the years, you will end up with this beautiful number of 30 million years. Okay. Hard to believe, but there it is. So, but now this other number of 3 million was for if you were to count each grain of sand individually. Each grain of sand individually by the same count calcula, it would take 3 million years to count them all. Okay. So this is because it's a tenth of that other number. So instead of 30 million years, it'll take 10, that many years. 3 million years, sorry. And how many stars are there in the universe? Just to get another feel for it. So this 10 to the power 24 stars is approximately how many stars there are, which is a lot of stars. But now you know this number 10 to the power 24, which means 1 followed by 24 zeros. It's not a lot of stars, but it's a Yotta stars. So now if you take 100 grams of sand, just 100 grams, you know how much that is, right? So it's just like quarter pound of sand. Then if you count all the atoms in that 100 grams, then you'll approach this number. So it has more atoms than all the stars in the entire universe, mind you, not just the Milky Way, the entire observable universe. Sorry? 100 grams of sand has more atoms than all the stars in the entire universe. And how many atoms are there in the universe? It's 1 followed by 84 zeros. Okay, that's how many atoms there are in the entire universe. So 1 grain of sand has about 1, you can say 1 or 6, doesn't even matter at that point, followed by 19 zeros. Whereas if you keep going and count all the atoms in the entire observable universe, you'll get 1 followed by 84 zeros. Now 1 followed by, all these numbers have names. Okay, I'll go to that later. But it's still short of what is known as a googol. Googol, by the way, is a new term for a lot of people, but it is a 1 followed by 100 zeros. So if is Sophia around, Karishma?
Yeah,
Hello?
she's here.
She's here. Okay. So Sophia, 1, and then if you write, you know how to write 100 and 1,000 and 10,000 and so on. So if you keep adding zeros, zeros, if you write out 100 zeros after the 1, you'll get a number that is called a googol. So if you feel like it, if you want to take a piece of paper and a pen or a pencil and write down 1 and then 100 zeros after it, let's see what that looks like if you want to do that. And that name of that number, like just like we have 100,000, million, quintillion, quadrillion, septillion, that 1 followed by 100 zeros is known as a googol. By the way, this googol was actually the name that that was the original name for the famous Google. And apparently there was a mix up between the concept and the artwork, and somebody misspelled it and it ended up being Google. But their original idea was to just indicate that they have, you know, so much data that it's as much as a Google worth of numbers. This number was named in 1920 by the nephew of a mathematician whose name I'm forgetting. But some kid named this number Google and decided to, and that's the number, the name that has stuck. So how much is a Google? We want to know how big is a Google. 1 followed by 100 zeros, okay, but how much is that? So let's delve into that one. Before we do that, let me show you what these, so this everyone can learn, right? I mean, so I'll show you how to do it. So if you have 6 zeros, you have a million. If you have 9, let's skip the 7 and 8, but 6 zeros is a million. 9 zeros is a billion. So we keep adding three zeros. 9 zeros is a billion. 12 zeros is a trillion. 15 is a quadrillion. 18 is a quintillion, sextillion, septillion, octillion, nonillion, decillion. Okay, then you're up to 10 to the power 33. Still not up to the Google, and still not up to the number of atoms in the universe. And then undecillion, duodecillion, keep adding three, and you come all the way to non-novem decillion, and then you come to vigintillion, and then unvigintillion, duovigintillion, um, uh, trivigintillion, quadrivigintillion, quintivigintillion, and all that, all that. It keeps going, and you end up finally at this 100. And this is 1 followed by 100 zeros, what that looks like, and that's the Google. And now if there's one more number that actually has a name, and that's a centillion, and that's a 1 followed by 303 zeros. Okay. And by the way, this is still not the largest number that is known to mankind. We'll go to that. But Yotta that we originally started with stops pretty early at 1 followed by 24 zeros. It looks pretty small now after looking at all this. But that's what a Yotta is. A Yotta is 1 followed by 24 zeros. And you heard, or everyone has heard about megabytes and gigabytes and terabytes and all that. And here's what those look like. So megabytes are a million, gigabytes are a billion, terabytes are a trillion, petabytes are a quadrillion, quintillion, sextillion, and septillion is where you end up with Yotta. So soon, you know, we are all used to gigabytes of memory and gigahertz of bandwidth on our internet. Soon we'll start hearing about terabytes and petabytes. And by the time our children grow up, everything will be probably in the range of zetas and yottas in terms of memory and speed and whatnot. So that's where we're headed. So that's the how these numbers look. And the other end of the spectrum, which is the minus, the smaller numbers, 10 raised to 0, then -1. In other words, 10, 1 divided by 10, 100, 1,000, 10,000. The names remain the same. You only add the th and you get that. So the 6 zeros is a millionth, 9 zeros is a billion, trillion, decillion, duodecillion, so on. So 1 divided by 100 zeros would be 1 Googolianth. Everybody knows this. Okay, great. So, so how do we visualize a large number like a Google, 1 followed by 100 zeros? So there's this brilliant guy named Daniel de Bruins who made this way for us to visualize what this will look like. So let me just share this video really quick with you. What time are we at? Okay, we're 5 minutes to 9. Okay, great. So here's this video. Everyone can hear me because I'm since I'm sharing the screen, I cannot see anybody. Are you guys there?
Yes.
Yes, yes.
And you can see the screen, yes?
Yes.
Yes,
Yes,
yes.
yes, yes.
Okay, great. So wait, I'm going to make sure I have the video on and I have the share screen, the video sound. Okay. So I'm going to share this video. So we want to get a sense of how much is a Google. Okay. And that's what we're going to look at this machine, which will help us visualize. Just like our count calcula, this is another way of visualizing this Google number, 1 followed by 100 zeros. Here we go. Why isn't that working? Okay, so you're about to see this incredible machine that this genius of a guy made. And here. So let me explain this machine a little bit and then you can enjoy the video. But this is nothing but what is known as a reduction gear. So this big wheel is connected to a small wheel next to it, which is 1/10. In other words, when this guy rotates once, that small wheel will also rotate once, but it will only cause this next wheel to rotate 1/10 of a time, 1/10 of a circle. So when this wheel rotates 10 times, this wheel will rotate once. Then when this wheel rotates 10 times, the next one will rotate once, and so on and so on and so on. Okay. And so this keeps on going up. So there are 50 wheels over here, 50 wheels over here, and let's see how this works. So as you see, the first wheel rotates a lot more than the next wheel. Next one rotates less, yeah. The video is coming out a little choppy, but you get the idea. So what's happening here is this first wheel rotates 10 times. This wheel will rotate once. This wheel rotate 10 times. This wheel will rotate once. This wheel will rotate 10 times. This wheel will rotate once, and so on and so on and so on. So now, basically, okay, let me show you the next video, which is another. Yeah. You guys are able to see and hear this video?
Yes.
Yes.
Yes, yes,
Okay.
yes.
So in this video, he's just letting the machine run for an hour, just without changing anything, just keeps running it, running it, running it. Yeah, so you see how this, if it takes 10 turns in the first one, this turns once. Then if this one turns 10 times, this one will turn once. And so on and so on. This will keep on going for 100 gears. Okay. So and you get, so if you keep going like this, right? Let's see, in almost an hour has gone by in this video. And you'll see that this machine has moved many times. This gear has moved less. This even less. This just hardly moved. And so on and so on. Right? So this is what is known as the reduction gear. So now if we keep going, so any questions on this machine? Everybody follows what's going on here? So if you keep,
question over here.
yeah, who
I
is
have a
this?
question. This is Aban over here.
Yes.
Uh, uh, this machine that was being rotating,
Yeah.
the first wheel was rotating on a higher speed. Okay. We
Right.
could monitor the second and the third and onwards as to how many circles it has completed with that white line, correct?
Correct, correct. And all the way through all 100 wheels we could monitor.
Correct. But how do we monitor how many times the first wheel has rotated?
I mean, we know the speed at which the motor is running, for example.
Okay.
So let's say the motor is running such that you have one rotation per second, rotation per second. So 60 RPM. It's a fairly good speed, 60 revolutions per minute. So one revolution per second. So the next wheel, one revolution every second. The next wheel will take one revolution. How many seconds?
No, what my question is, if the machine, if it has to run for 100 years, as you said.
Yeah.
My question is the first wheel, okay?
Yeah.
How many rotations will it take in that 100 years?
No, that we can figure out based on how fast the motor is that's running the first thing.
Achha.
Depending on how fast that motor is, but a fairly fast motor would rotate it one every second. Let's say once every second. That's pretty fast.
It would be the Google. If it does the whole thing, that's how many it would be.
Exactly, Karishma. So my question is, how long will it take before that last wheel, the 100th wheel, will go through one revolution, one rotation? Of course, so the first wheel will have to turn one Google times before the last wheel will rotate once. So the first wheel takes 1 second for one turn. This next wheel will take 10 seconds before it will turn once. The third wheel will take 100 seconds, then it will turn once. 1,000 seconds, 10,000 seconds, 100,000, and then million, and so on and so on. Multiply by 10 every time you go to the next wheel. And if you go all 100 wheels, by the time the last wheel will turn one turn, the first wheel will have taken one Google seconds. One Google seconds would have passed, and it would have turned one Google times before that last wheel will turn once. You understand? And so now the question is, correct. So that was actually going to be my pop quiz. How many seconds will pass before the last wheel will turn one rotation? And Karishma already gave the answer, but I hope everyone understands. More or less. See, it's like this. The second wheel will take 100 seconds. Will turn once after 100 seconds. Third wheel will turn after 1,000 seconds. Then 10,000 seconds. Then 100,000 seconds. Then 100,000, which is a million. Then 10 million. Then 100 million. Then 1,000 million, which is 1 billion. Then 10 billion, 100 billion, 1,000 billion, which is a trillion. Like that many seconds. Every wheel you have to keep multiplying, adding 110. And each wheel you add 10. So by the time you reach the 100th wheel, you must add 100 zeros worth of seconds. Okay. Now, question for everyone. Take a guess at how many how many years that Google seconds is. How many years is a Google seconds? Any guesses? हाँ बोल बोल बोल.
It's a tenth of a Google, whatever.
What? It's
Like-
not a tenth. But
No,
how
it's
many
not even-
years? How many years is it?
365 days, or I don't know.
Uh,
Sanjeev,
okay.
simple answer infinity.
Good one. I like that. I like that answer. It'll take you are as close to right as you can get almost, because it will take almost an infinite amount of time. But Pratibha Ben said it'll take infinite time.
Perfect answer.
Yeah. So
Uncountable number.
right. So how long will it take before the last wheel turns? Okay, it will take 1 followed by Google zeros seconds, which is how much? Any guesses? Okay. Which is
Oh my God.
these many seconds is 1 followed by 73 zeros.
0.
73 zeros multiplied by the entire age of the universe today. Today's universe is from the Big Bang till now. Physicists tell us about 13.8 billion years have passed, which is how many zeros, everybody? 13.8 followed by billion. Come on, guys. How many zeros for a billion?
9.
9 zeros. So that many years have gone by since the beginning of time as we know it. So the universe would have to pass this much time, not 73 times, but 1 followed by 73 times the age of the universe. It's just it's just like Pratibha Ben said, it's as good as infinity. But just to put numbers on it, the universe will have to live some duodecillion times. Let me go back to the 37, 72 is approximately this many times. We have only crossed the universe one time so far, but we'll have to do it this many thousand million times the age of the universe before that last wheel will take one rotation. Can you imagine? So somebody raised another question. Somebody raised another question to this guy, Daniel Bruin. They asked him, and I'm asking you guys, if you turn the last wheel, okay, at let's say 1 revolution per second, what will be the speed of the first wheel? Because now if you're going in the opposite direction, here we were turning the first wheel and making the next wheel move, and so on. The question is, if you made the last wheel turn, how quickly will the first wheel rotate? Any thoughts, any ideas?
Faster than the speed of light.
You are not only, you're right, which is not possible, by the way. Nothing can exceed the speed of light. No matter can exceed the speed of light. So this wheel is not going to go at faster than the speed of light. But the problem with it is you cannot turn that wheel at all. The amount of energy, the torque it would take to turn that last wheel is more energy than the combined known energy in the universe. To just turn that wheel once will take more than all the stars, all the suns, everything put together, more work, more torque, more energy than all that the universe's energy cannot turn that last wheel even once. So that's how big that is. Okay. And if you do that, this thing is going to fly into the next universe. That first wheel, trust me. Okay. So, so let's play with a little bit of these big numbers. So what is your age in seconds? Did you know that most of you have crossed a billion seconds? At age 31.7 is when you become a billion seconds old. Okay. So my age, which is more than twice of this number, I've already crossed 2 billion.
And I've crossed 2 billion too.
You crossed 2 billion too, Harsha. And to reach the 3 billion second mark,
You have to be
we'll have to get to 95.1 year old. Then you will live for 3 billion seconds. Okay, so now what's bigger number than a Google? So if you take a 10 and then follow that by a Google zeros, a Google has 100 zeros, but you take one and then follow it by a Google zeros, you get what is known as a Googleplex, which is the much bigger number than the Google. Yeah, we can all faint at the sound of this number, but at least now we know its name. It's called a Googleplex. And then what is the biggest number that can be used in mathematics? It's called Graham's number. And actually they are finding some number now which is even bigger than this. But how big is a Graham's number? If you take, remember the Planck's length of 10 to the minus 35 meters. If you make a cube of 10 to the minus 35 meter by 10 to the minus 35, the smallest tiny means you can't even imagine that tiny a cube. And you write a digit inside that cube. Okay. And you take the next cube and write the next digit of the Graham's number. And like that, you fill up these cubes with one digit. Then you don't have enough room in the entire observable universe to write out the Graham's number, all the digits of the Graham's number.
Oh my gosh.
It's a crazy number. And yet they're able to represent that number with this combination of notation and whatever. It's not even Googleplex raised to Googleplex. That doesn't even come close. But this is like the biggest number that mathematicians have even found out. Graham's number. So it would not fit inside the universe, even at that tiny little scale. Every single planet, every single star, and all the space in between, you fill it up with this number, writing it. You don't have enough space. So that's how big it is. That's the Graham's number. Okay, so now that you know what millions and trillions and billions and all that numbers looks like, just just a few what did I want to share? Okay. Yeah. So in 1 cubic centimeter of air, you have 10 million trillion. Now everyone knows how to do this. Million is 6 zeros. Trillion is
12.
12 zeros. 12. So 12 plus 6, 18. That's how many. So 1 followed by 18 zeros is how many atoms are there in 1 cubic centimeter of air. Okay. And then there's only 1 per cubic centimeter in the void between the stars and 1 per cubic meter in the void between galaxies. The Earth is 5 followed by how many zeros? 9 zeros. 9 zeros years old. 1 light year means how the speed of light is 3 times 10 followed by 5 zeros kilometers every second. And in 1 year, that light will travel this many kilometers, which is 9 and 3. So that's 12. So that 12 means you're talking about a trillion, 3 trillion miles. The nearest star is 4.3 light years. So you take this 1 light year distance and multiply by 4.3. That's how far the nearest star is from us, which is Alpha Centaurus. And so on and so on. These are all, all these billions and billions and trillions and all these numbers that you can now get some sense of by thinking how long it'll take to count them. Okay. So Andromeda, the nearest galaxy, 70,000 light years. I mean, we are talking just incredible distances and incredible amounts of space and numbers and incredible numbers of zeros. But now I don't know if you guys heard the tabla that was playing in the beginning, and let me just play that for a second. Maybe we don't have time for that. So let me just go through this. So now let's think about the power of the human brain. We've seen all these zeros and all this stuff that's going on, and for us to logically understand it, it takes us all this effort and all this, you know, knowledge and understanding and time. But the brain is coordinating and managing the activities of 15 trillion cells. Each cell has hundreds of biochemical reactions happening every second. And all these are controlled reactions. If something goes too high, it knows to slow it down. If something goes too low, it knows to speed it up. Whether you're talking about insulin or the electrolytes in the body or the, you know, all the different hormones, all that stuff is produced by all these 15 trillion cells. And this brain of yours is regulating, coordinating, managing all 15 trillion cells simultaneously, effortlessly, automatically. The brain is capable of dividing and calculating and multiplying huge numbers without a thought. Like logically, it takes a long time. But think of an acrobat or a tennis player or a cricketer. The amount of calculations that are going on to do one somersault or one cartwheel, Sophia, is unbelievable. You need to know your height, your weight, the distance to the ground, the weight of your body, the resistance of the ground, how long it'll take to get there, how much effort you need to put. All this calculation is happening, and you know, Sophia does 3 cartwheels in a row, no, not without even blinking an eye, and that calculation is happening automatically. When we sing a single note, one note, you know, it's exactly at certain frequencies. 440 hertz, for example, is A, the note A, and that's 440 cycles per second. So we are somehow calculating and counting 440 of these vibrations of sound and know exactly how much, where to stop. It's unbelievable. When we dance or play a beat, we are dividing time into precise intervals. Like that tabla that was playing in the beginning, right? Da, din, da, da, din, da. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3. And the guy was going, da, din, da, da, din, da. So in that interval of 1, 2, he's dividing this interval of 1 into 16th, 32nd, 64th, 128. This interval is being divided by our brain, by the brain of that tabla player, into 128, sometimes as many as 200 equal parts. Just this one beat, 1,000, and it's divided into 128, 200 parts equally, precisely, and perfectly. This is what your brain is capable of. So this is what's happening. So on the one hand, logically, all these numbers are way beyond us. On the other hand, as a natural ability that the human brain, you and I are born with, we are dealing with billions and trillions and gazillions and quintillions without even like batting an eye. So this is the power of the brain. So, and then what is beyond that then? What's beyond the brain? And so we come to the the ultimate the ultimate source of wisdom, the ultimate source of knowledge, which is that in which the brain resides, not the head, but the consciousness. Because the current model of science is that, you know, we started with single cells and then complex cells and the human being and then the brain and then consciousness somehow emerged as a result of the brain. But if you even think for 1 second, you know that without the presence of consciousness, there is no experience. There's no reality without the presence of consciousness. Consciousness comes first. Um, and this consciousness, which is the source of all, is where is even a, a Googleplex or Graham numbers times more complex and powerful and infinitely more beautiful than just our limited human brain. It is limited, by the way, Of course, we know it is limited. We don't understand so many things. So, so just to end this on the edge of what we understand and edge of what we know, just I want everyone to let me close this. So I want everyone to just close your eyes and ask yourself the question, am I present? And now ask yourself the question, where did I go to find out that I'm present? And I'm assuming everyone answered with the yes when they said, are you present? The answer is yes, I'm present. Ask yourself where you went. You are certain that you are there, but it is not, you did not go to your name, you did not go to your body, you did not go to your thoughts, you did not go to your feelings, you went to your awareness. And whatever activity is happening in the brain, what happens in the brain? Thoughts, feelings. Notice that all of these must happen to somewhere or in something. Thoughts must happen in something, to something. The sensory perception, sight, sound, everything happens to somebody. There is an experiencer of all experiences. And that this experiencer of the experience includes the experience of brain, includes the experience of this body. So rather than the mind or the brain being a something that produces consciousness, we notice that consciousness is the container of all that there is. And this is the true reality of who we are. And notice that for consciousness, which can become conscious, which is conscious, not just of the body and the mind and the thoughts, but of each and everything in the universe is created. Consciousness lends existence to all that there is. Unless consciousness is present, existence of anything is meaningless. Without the presence of consciousness, stars, sun, the earth, people, you, me, has no meaning. It is only the knowing of all that there is which affords existence to all that there is. So while the brain finds it difficult to wrap itself around these tiny, tiny, tiny things like electrons and even smaller, consciousness is the creator, the manifester, the fabric out of which all things, from the tiniest to the largest, is created. And it is who you are. So, infinities of time, eternities of time, infinities of number are a natural property and a capability of who you really are. And the more we can tap into this infinite source of knowledge, infinite source of information, the more our understanding of all that there is grows. Notice thoughts come and go, notice feelings come and go, and you remain. You who can think of, perceive, imagine, the tiniest electron to the entire universe. Wonderful. With that thought, you may open your beautiful eyes and turn on your videos if you guys if you can, please turn on videos so we can see you and say goodbye. And
સંજીવ
yeah.
તો આપણે જે આ ગ્રેન શબ્દ છે ને આપણે માઇગ્રેન કહીએ કે માઇક્રોગ્રેન તો આના જ અનુસંધાનમાં હોય છે.
No, migraine has to do with like a chronic headache. That's just
માઇક્રોગ્રેન કે એવું કઈ વર્ડ હોય તો
micrograin is a separate word which has nothing to do with migraine. Micrograin only means a grain of, but a 1/100,000th of a grain is a
તે જે
micrograin.
ગ્રેન નું ડેફિનેશન આપી એના અનુસંધાનમાં જ હોય છે ને માઇક્રોગ્રેન.
Micrograin is about that, but migraine is completely
માઇગ્રેન
different.
ઇઝ ડિફરન્ટ.
Migraine is a headache, is a chronic
ચલો
headache.
થેન્ક યુ.
Welcome. Great. So anyone, any questions or comments before we close?
બાકી તો
On-
anything multiply by 0 means 0. એવું
Yes,
છે.
yes,
આ
yes.
બધું એટલું ગોળ ગોળ થઈ ગયું.
Right.
Do we need to give a
Imagine.
title to this so that the video can go up?
Yeah, we can. This is about numbers so we'll call it the same as the title of the thing, from Yotta to Yotta.
Yotta.
Numbers
Yocto
and
to Yotta.
consciousness. Let's call it numbers and consciousness. Dash Yotta to dash numbers and consciousness. So and by the way, all numbers are imaginary.
Mini to maxi also. Mini to maximum.
Yeah, something like that. But all numbers are imaginary, by the way. They don't exist. Numbers don't exist. Only things exist. Numbers is merely a concept. A number is an idea. Numbers have no actual existence. Numbers do not exist in reality. It's just a concept. So these small numbers, big numbers, all are concepts, which only for the purpose of helping us understand the smallness of something, or the quantity of something, or the volume of something, or the distance of something. Number in itself doesn't exist. You never saw a number in your life. You've never experienced a number in your life. You've only seen things. You've only heard things. You've never heard a number. It's just a concept. It's just a mind construct. Okay, anyone else? Anyone wants to share their experience, their insight, or their whatever? Yeah, welcome Pragati. Thank you for your comment. Wonderful. Who else? Anyone?
Fantastic.
The entire ocean in one drop.
Say that again. I turned off recording. I want to get this on. So start again. Rumi's quote.
His quote is, "You're not just a drop in the ocean, you're the entire ocean in one drop."
You are the entire ocean in one drop. Exactly. Even though we have these limited bodies, you are actually the entire ocean, even though you are just one drop. Beautiful. Yeah, thank you for that. And thank you for your participation and your prompt answers. And, for everyone's information, Karishma is my daughter, lives in the US, and she's a medical doctor. And for you, Karishma, to come to, you're dealing with the human body every single day. And yet, we forget how fantastic and miraculous this whole thing is. So beautiful. So
Yeah,
I'm glad this came across to you that way. Neha, please put your number in the chat box so we can add it to the...
I have a request. Can you share the PPT on WhatsApp group? It was quite interesting because we could not see the display very correctly.
Yeah, sure. I'll post it on the WhatsApp group. Sure.
The PPT only.
The PPT I will post, and we'll also be posting the recording itself of the whole thing. But the PPT also you're welcome to have. Yeah.
Thank
you.
Thank you, Master.
And we need to thank you, Sanjeev ji, for doing so much of research for us and bringing so much information. So thank you so much.
Yeah, most welcome, because I had so much fun getting all this together, because I have the same questions that all of you have,
This
See,
is beyond our limit, beyond our mind. I can't understand only. There is something very much new for me.
correct, correct, correct.
Just a born
Ordinary.
baby. Just a born baby.
Yes, but that's the fun part. You be a born baby all the time, and the whole world of knowledge and information and beauty is available to us to learn more and more. In
I'm
fact,
really very happy. Yes.
thank you, thank you, thank you. And even if we have a PhD, we can be like babies in the world, right? And
Yes.
that's the only way we can learn new things.
Thank you very much, Master. Thank you. Thank you, Sanjeev.
Okay, great. Thank you, thank you, thank you. We'll end with a intention that this knowledge bring truth, love, beauty to all people and free them from whatever binds them and bring more and more joy and freedom from suffering. Om Shanti, Shanti, Shanti. Hari Om Shri Gurubhyo Namaha. Hari Om Tat Sat. Thank you, thank you, thank you. Wonderful.
Thank you, sir. Thank you so much.